Hello guys, welcome to my channel. This is Rosario Borgesi and in this video we will explore the Solidity data types. We will discover both the value types like strings, booleans and integers, and we will also discover the reference types like arrays, mappings and structs. So let's get started. So I have created this Medium article that will guide us throughout the video that you can find in the description. And I would like to start by pointing out that Solidity is a statically typed programming language, which means that for each variable that we declare, we must specify the type, and this is similar to Java or also TypeScript and different from dynamic languages like JavaScript or Python that are dynamic, and so the compiler only knows at runtime which is the type of the variable. But here the Solidity compiler knows the type of the variable beforehand. The main distinction that can have the Solidity types is very similar to other programming language, like for example Java. And the basic difference is that there are value types or reference types. Value types means that each data type has its own independent copy. Um, like for example integers in Java or all the primitive types, while reference type store a location, a reference to the actual data, and this is similar to objects, for example in Java. And additionally, we can say that variables of value types do not share memory location. So this means that if we change the changes of one variable, um, mm, the variables are copied whenever we use them in function assignments or function arguments, sorry, or in assignment. And for example, if we modify one variable, that will not affect the other variables at the same time. And of course, this is different, as we said earlier, for the reference type. So the value types now comprise booleans, integers, addresses, contract types, fixed size, byte arrays, strings, enums, function types. Let's start from the booleans. And let's say that booleans are represented in Solidity with the bool type. And like all the boolean types in all other programming language, they can only have two values, which are true or false. If we don't assign the variable, so we not initialize it to a specific value, for example, like here, the variables is defaulted to false. I forgot to mention that in Solidity there is no the concept of undefined or null, like for example in other programming languages. And if you do not initialize a variable, it will be defaulted to the default type of its type. For example, in for bools it is false, for integers it is 0, for strings it is an empty string, and so on and so forth. The operators that you can apply to the Boolean types are similar to all other programming language. You have the negation, the and operator, or operator, equality operator, or not equal operator. And here are some examples. For example, if we define a variable, we define two variables, bool1 and bool2. One it is false and one other it is true. The not operator gives us the not operator applied to a false variable gives us true, while the end operator outputs false. The or operator, in this case, between always false and a true gives us true. The equality operator in this case gives us false, and not equal operator gives us true. Of course, we can make use of the IDE that is provided us by Ethereum, which is Remix. And for example, here I have created a contract which is as the Solidity version of 0.8.25 that will demonstrate all these statements that we have discussed before. And we to test these values, we have created some assert declaration. So if the assert this assert statement is not true, the function test will revert. This function has been declared public because it can be called from outside of this contract, and pure because it does not, this is a function modifier in Solidity. This function does not read or modify the state variables of the contract. This contract in particular has no state variables. But we are not even reading the global variables, so we can use the pure modifier. And so the contract has been already compiled because it is auto-compiled. We can deploy it to, for example, the Sepolia test network by using MetaMask. So I have here my MetaMask extension. I've created the MetaMask account, which is an Ethereum account basically, and this account is pointing to the Sepolia network. So injected provider here means that we are using this account to deploy to the Sepolia network. Of course, we need to add some test ethers to our account. I already have 1.5 ether, but you can find the link to a faucet to acquire some test ethers, which are free, that allow us to run the code in Ethereum, because as we know, in Ethereum we must pay the gas fee in order to run the code, and so we need some test ethers because we do not waste our real ethers on the mainnet. So we can deploy the contract. This was an earlier contract, so I can remove from the pin the contract. I confirm the transaction, so it is deploying the contract. The transaction is pending. So okay, transaction has been confirmed. The contract has been deployed. We can run the test function, and you can see that everything went fine. If we, for example, here write an assertion that is false, that is not true, and we once again deploy the contract. We deploy the contract. Okay, we once again run the test function. Now the function reverts because we have written a false assertion. So this is a good method to test our code, to test our variables, our function, whatever we want, we would like to test. So now let's get back to our article. Then we have the integer types. The integer type is comprises integer numbers, which means in numbers without decimals, and they can be represented in two ways. In Solidity, they can be represented with signed integers, which means they can be either positive or negative, or unsigned integers, which can only be positive. So um, the type int and uint are available in increments of 8-bit, which means that we have uint 8, uint 16 up until uint 255, and the same holds true for int types. What does it mean? This means that the range of numbers that this number can store, it is different. For example, in a uint 8 you can hold a uint 8 can hold the numbers from 0 to 255 and so on. And this here are reported the range of numbers that you can calculate with this, for example, for uint with this formula, and the same thing for the int types. So the int 8 can hold the numbers from minus 128 to 127. This means that very essentially that if we assign, for example, 127 to int 8 variable, this can be done because the range goes until 127. If we assign 128 to an int 8 variable, it gives us a type error because this variable cannot hold this number. It exceeds the range of number that the int 8 type can hold. So, as we said earlier, there are also for these types, there are the supported operators that we see in all other programming language, like the comparison, less or equal to, less to, equal, not equal, greater or equal to, greater than. Okay. The bit operators, also there are the shift operators and the classic arithmetic operators like plus, minus, times, the division, the modulo operator, the exponentiation, and so on and so forth. Here there are some examples. Also here, if we like, we can create a new, for example, integer contract. Okay, let's say that this we replace with this. Sorry, I have deleted too much. We retain the test function. The contract will be called also integers. Okay, here I miss this parenthesis. Okay, here we can add, for example, some assertion. So assert that, for example, this variable is true. Okay. For example, this other variable, the sum is sum variable equals to 7, or also that um, the subtraction variable equals to -3, or for example multiplication is equal to 10. Also we can test all the variables I'm giving you some examples for, then you can continue. Exponentiation is equal to 8, for example. Then you continue. This also was declared as a view, so the compiler tells us the function state mutability can be restricted to pure, because we are not reading any state variables here. It tells us that this variable is not used, but um, we can it is not interesting to us. So the contract is okay, because here it is green. It is already been compiled. We can, like before, deploy this new contract. Here it tells us that we are deploying the integers contract. We say okay. We wait until our contract has been deployed in the Sivolia test network. Okay. Now the contract has been deployed. We can call the test function, and the function here is reverting. Now we should understand why it is reverting, and we can do it one step at the time. This is what you do in real case scenario. So you deploy this contract again. Okay. This went fine. Okay. Then we add this other piece here. We are trying to understand what is not working. We are making some bug fixing. Okay, this is fine. Let's try this out also, because in real life things do not always go fine, and we need to fix them. Okay, this was fine. Let's try also this case. Okay. Here, of course, was the problem. I could not see in earlier, because, of course, multiplication, well, it is a product between two numbers, cannot be negative. So here there was a typo. Multiplication is 10. So I believe that also the other tests are fine. I deploy this new contract. Remind you that each time that you deploy the contract, you pay the gas fee. So you need the test ethers in order to run all these deploying all this transaction. Okay, the contract has been deployed. Here run the test function. Okay, it was fine. So you can continue with the other assertion, other tests if you like. Okay, now let's see another type of Solidity type. So we arrived to fixed point numbers. Fixed point number in Solidity should represent decimal numbers, but in reality, Solidity does not still support decimal number. So we cannot. Solidity is a language which is not that old. It was born maybe in 2015, so fixed point numbers or decimal numbers, floating point numbers, double types, float types. I don't know how you know it by other programming language, which basically means decimal numbers. Decimal numbers are not supported in Solidity. So this means that we, for example, can have if we need, for example, to use decimals, which is something that it is done, for example, in the ERC20 tokens, for example, when you create new cryptocurrencies. Like, for example, an example in ERC20 token can be, for example, Tether. You can, I have also created a video about the ERC20 token if you like. For example, we can use a workaround here, so we can create we can make use of mm, integers, positive integers, so uint, but we are creating a very great number. So then if we take into account that there is this factor here that represents our our decimal part, we can we can make a workaround to this problem. But of course, this should be fixed by Solidity. And so let's try, for example, this contract here, for example, decimal contract. I believe it is the same, but I will copy and paste. The contract is okay, it is compiled, we can deploy it. Okay. Okay, here, for example, our factor is 10 to the power of 6. So, which means that if we want, for example, add two numbers, for example, 1 and 2, we should write 1 with um, 6 zeros. So here I type 1 and 6 0. Then I can, for example, I sum this number to, for example, 4. So 4 with 6 0. Okay, I call the add function. Okay, it gives us this great number. So we, for example, if we must print this number in a front end, we know that this number has 6 decimals. So we divide this number for this factor, and we get the number 5. But of course, this is a workaround, and Solidity should provide um, a reliable type for this type of numbers. So this is an example for workaround for decimals. and there are also some libraries you can read something at this link here, but there are always their workaround, some workarounds because this type has not been um, it's not been developed. So let's move to the address type. The address type is used um, um, to model an Ethereum address. For example, like this one. This is an Ethereum numbers. This is my address of my account. You can see it which number it is. This number, for example, also a contract when it is deployed, it has a similar address. So this type allow us to uh, interact with contract that already deployed at some address on the blockchain, or for example, it can be also the address of a of an externally owned account, so a person, a user. So I delete this. Okay. So um, this address type can hold a 20 byte value, which is the size of an Ethereum address, as we said earlier. And there is also the address payable type, which is similar to the address type, but includes the member transfer and send. And this is used to if we want to send money, so ethers to this account. So in fact, the key difference between the two is that address payable can receive ethers, while a plain address type cannot receive ethers. We can convert um, an address type to an address payable by making use of the payable function. And okay, there are some implicit conversion from um, address payable to address, but okay. The operators that we can apply to this type are less or equal than, less than, equal to, not equal to, and greater or equal than, or equal than. So it is it is always it is like the other types that we have seen earlier. So these are some examples. Of course, if you like, you can write some assertions. And another important thing is that the address type have the balance or transfer method. So, for example, the balance type is used to query the balance of an address, and also the transfer method, as we said earlier, allows to send headers to a payable address. And of course, there are also some others member that contain some low-level function that the Solidity documentation do not suggest to use. To demonstrate the use of these two functions, balance and transfer, I have created this smart contract here that we can paste into our IDE remix, which is addresses. And basically, this address has a set of function, as you can see here, send ether, which receives an amount of ether and the address of the recipient. And so we, of course, require that the balance of this contract is greater of the amount that we want to send, and we simply transfer to the recipient the amount of money that we have received in the input here. Then we have the function get recipient balance, which returns the balance of the recipient. And also we have the contract balance, get contract balance, which returns the balance of this contract. So in the constructor, we of course require the, the account that deploys this contract provides a certain amount of ether, as you can see here. As you can see here, 0.01 ether. And so we in the test function, what we do this essentially. We take the recipient address, which is my address here of my MetaMask account. Okay. We establish that the amount of ether that we want to transfer is 0.001, and then we give here an estimate of the gas fee either for both the contract deployment and the execution of the test function. These are two values that I have, and these values are not precise because the gas fee can change depending on the on how the network is. And so we retrieve the balance of the recipient address, the balance of this contract. We send the money. We retrieve another time the balance of the recipient and the balance of the contract, and we assert that the balance of the recipient is greater than the balance of the recipient before the transfer plus the amount we are transferring and minus the expected gas fee. And also here for the contract after the transfer, the balance of the contract after the transfer must be greater than the balance of the contract before the transfer, minus the amount of money we are transferring, minus the expected gas fee for the test function. So we want to this is an handy function, an handy way in Solidity to represent the amount of ether that gets converted into ways automatically. So this is better than writing a long number in ways, but unfortunately, when we deploy the contract here in Remix, we are required to insert the value in way because in Ether we cannot insert. No, I'm sorry, it is working now. No, no, okay. We cannot put here decimal numbers, so we must use or ways or Gway. I will use way. I will take this amount that we are required to enter here. I go to an Ethereum converter that converts this amount of ether in ways. I copy this value here and I put this value here. So we are from our address, which is this one, we are transferring this amount of ether, which is 0.01, to the address that we are deploying on Sepolia. So with deploy, with confirm, it is starting the to deploy the contract. Okay, the contract is deployed. We can interact with the contract here. So we, for example, here it should, okay, now it appears that the contract has a balance of 0.01 ethers. We can get the contract balance, which is Here it is reported in ways. So we run the test function. Okay. Okay. The transaction was successful. I would like just to point out that when we deployed the contract here on Etherscan, you can see more details about the transaction, especially for the fee. Here you have the cost, the total cost of the transaction, which is 0.3 zeros and a 5. This is the total cost of the transaction, which is the multiplication of this value here times the gas fee. Okay? Which is also said here. It is the gas price times the gas used by the transaction. This is the total cost of the transaction. So the transaction has costed us 0.3 zeros and a 5. We have estimated in the deployment 0.005. So there is an order of magnitude more we have estimated, but this can vary depending on how it is busy the network. And also we can see that the second transaction, when we called the test function, we can see how much, how was the cost in gas fee, and it has been 0.2 4 zeros and a 4. We have estimated 3 zeros and a 5, so it is an order of magnitude less, but nonetheless the test is okay because we cannot know beforehand how much the transaction fee will cost, but this is useful also to help you understand how you can see how much you have paid for this transaction. And okay, we can get back to to our uh, our article. So that was pretty much it for the addresses. Let's talk about the contract type. The contract type basically it is used to interact with the contract, as you may guess, in a very in a straightforward manner. So each contract establishes its own type, and it is possible to explicitly convert contracts to and from the others type, as we have said earlier. So, for example, if we define a local variable of contract type, for instance, my contract, we have the ability to invoke a function on that contract. And this is an example. This is an example that we can try on Remix to understand what we are talking about. So this is the calling contract. Okay, I believe it's this one. Okay, it's this one. It was already copied. And so, sorry, the contract is already been compiled. This is the earlier contract. Okay, we delete it. And what this contract does, we have here the called contract that we deploy that has a basic function set x that sets this variable. So here what we are doing, we are creating a contract type of that refers to this type of contract, and this is set in the constructor because as you see in the constructor we will pass the address of this called contract here, and so we set this variable, and then we can call this function here that will change the variable in this contract here called contract. So we have to first deploy the called contract. Okay, of course we are running a transaction. Perfect. And we see that this contract is 0 because it was not set, and as we know, it defaults to 0 because it is a uint. So we have deployed the contract at this address here. This is the address of, no, this is the, no, I took the wrong transaction. This is the contract, okay. Okay, called contract dot constructor. Here we are calling the constructor. So this is the address of the contract that we have deployed. This, we delete this. Okay, now we want to deploy the calling contract, and we deploy it at the address of the called contract that we have deployed before. We deploy it. Okay. It should appear. Okay. The calling contract has been deployed. This is 0. So here we set, for example, 10. And we call this function here. Of course, we need to confirm the transaction. Okay. So here we should, now we see 10. And also we can check that the call contract is exactly what we have specified before, which ends with 875b. 875b. So it is working. And here we have demonstrated the type contract. So how to call a contract from another contract. Okay. Um, okay. Here there is another example where we say that another one contract we can also create another contract. So for example here in the contract C we are creating a new instance of the D contract by calling the new function, like the new function that maybe that we use also in Java, for example, to create a new object. In this case, we are using it to create a new contracts. And also here, you are creating a new contract, but we are passing here this argument. And this is another way of creating a contract, because here we are also not only we are passing an argument, but we are also passing an amount of ether on the creation. So it is another interesting case that you can also try for yourself. And then we pass to fixed size byte arrays. Similarly to what we have seen to integers, there are bytes arrays of fixed size from 1 to 32 bytes. And in general, we can assign a string, for example, a string literal to this type. to the bytes by enclosing it in double or single quotes. And of course, we do not have to exceed the length of the array. For example, here byte array has a length of 32 bytes, so these are 32 bytes and it's okay. If I put here 33 bytes, I will get an error. So this is not allowed. And also the operators that are supported are always very similar to what we have seen earlier. It also has the member dot length, which yields the length of the array. And there you can see there is a method in this contract. Essentially, it is a contract that receives strings and converts it into a bytes array. Okay. Uh, this can also be a good example to try it if you like on yourself. And of course, it is important to note that this type has a concat function that allows to concatenate a various number of bytes into one byte array. So another important type, maybe the most important type, one of the most important type that we use the most in each programming language are strings, and strings can be written with double or single quotes, like in this case. And of course, there are some escape characters that are supported, like backslash, tab, double quote, single quote, like in all programming language. Also here you have the string concat, the concat method that allows to concatenate a variable number of strings. And so at this time you may be asking, but if or, if bytes and strings can be associated with a string, okay? So with a sequence of character, when do we need to use bytes or strings? The main difference here is that the string is not limited in size, while bytes, as we have seen, are limited. But strings um, um, differently from bytes does not allow to use the length to get the length of the array, and does not allow to access a particular index of the string, which is something that we do in all other programming language. And Solidity does not have function for string manipulation, but there are some third-party libraries. If we want to compare two string, we need to use this. This is similar. This Kekkak 22056 hash is an algorithm for hashing similar to the SHA. No, if similar, for example, SHA-3. There is a little difference between the Kekkak 22056 algorithm and the SHA-3 algorithm. And to compare two strings, we have to use this this expression here. So we firstly take the string and convert it essentially to bytes, and then we to the This is the how the object it is encoded in the ABI. And then we apply this algorithm, and so we compare these two algorithms to compare the two strings. We can concatenate the strings by using the string.concat. Okay, and so as a general rule, we should use the bytes for arbitrary length raw data byte and strings for arbitrary length UTF-8 data. Um, of course, if we know beforehand that length um, can be limited to a certain number of bytes, we can always use bytes 1 to bytes 32 because they are much cheaper. Um, of course, here we can retrieve the byte representation of a string by using this expression here. And so in the following, there is an example that will demonstrate how to use string. So string operations, maybe it is the same, but so as we have seen, it just has a bunch of methods. So concatenate to concatenate two strings with string.concat, compare two strings with the expression that we talked earlier, convert a string to its byte representation, and to get the string length. And so we can deploy this contract. Okay. And of course, here in the test function, we are making an example of concatenation of string. We are using also the function string compare, and we are also calculating the string length. Okay, so we run the test function. Okay, it is okay. Everything went fine. So another thing important is that Solidity does not directly support the conversion from integers in int or uint to strings, so we need to write our own function to accomplish this. This is another example that where have been created the two function int to string and uint to string to make this conversion from ints to string from uint to string that you can try also that we can also try on Remix. So this is the another integers contract that we and we will replace the earlier contract. So there these two function has been defined. There is the function to compare the strings that we have seen earlier, and here basically we are essentially creating the same operation that we did before, the sum, the exponentiation, and then we test, make some tests to where here we compare the variables that we have calculated. So we are comparing strings, integers, sorry. Here we are converting the integers to string in these two function, and then we are comparing the strings with the expected one. Okay, so we can this is useful because it always happens that we have to make this conversion from integers to strings. We can deploy this contract. Okay, and we can run the test function. Okay, perfect. Everything went fine. So this is another example. And another type that is important, maybe you know it if you come from Java, is the enum, and where you define a set of constants variables. Um, but here in Solidity, the enums are slightly different, and they can be explicitly converted to and from all integer types. Um, so we can use also this two expression here to get the smallest and largest value of the enum. And here you have an example, a contract that demonstrate this type. This is called the shipping status. There is, I have to create the contract. So I create new contract, shipping status. Okay, place the contract here. So as you can see, we are defined some shipping status: pending, shipped, accepted, rejected, cancelled. This value pending is 0, shipped 1, cancelled up until cancelled, which is 4. And you have a series of functions to demonstrate this type. So get returns the status, sets the variable, global variable here, status to here you retrieve with get you retrieve the global variable status. Here you set this this status variable. Also, maybe the get was with public is worthless because it already generates public getter, so we can write the private. And so we have get set to set the status, cancel to set the status to cancel the number 4, reset which resets the enum to the first value 0, so pending. And so to get the largest value, we have here we use type status dot max. Here we use type status dot min. So this is a test that demonstrates this. So if we set the status to accepted, we we get the value, and to make sure that it is equal to accepted, here we write, for example, cancel. We test that the status is cancelled. Here we reset. So we test that the status is pending, and here we test the two function: get largest value, get smallest value. Also, we can deploy this contract. Okay, and we can run the test function. Okay, everything went fine. So this works. Then we have the function type. The function type is a type associated to a function. This can be also used, for example, as a parameter of a function, and basically there are two kind of function, internal and external function. So internal are restricted, can be called only inside the current contract. External function may be called from other contract. This is how we can define this function type. Um, other other important things here is that by default the function type are internal. Okay, here we have the concept also of payable function if we want to accept payments with our function. Um, okay, and then it is important to say that if we call the dot address method, it will return the address of the contract of the function, and the dot selector returns the ABI selector. Also, we can express the gas and the value if we want to express the amount of gas or amount of whey in a function. And here we have a simple example of a function type, as you see here in this function, accept another function as a parameter. Um, and so here we define a square function, and we pass the square function as parameter to the execute function here, and we assert that since we are calculating the square of the um, uh, of this parameter that we are passing here, this value here, it should be 3 to the power of 2, and so it should be 9, the answer. Maybe it was not right here to call it square, but it was better to call it to the power of 2 or something. So we can try. So let's try this function here on Remix. This is called function type example. So here we use function type example. And so as always, we will deploy the contract. Okay, and we call the test function. Okay, everything went fine. So it is correctly squaring the input. And so then we arrive to the reference type. The reference type, we said earlier, contain a reference to the actual data. So reference type share the underlying data, and change made to one variable affect other variable that reference the same data. It is the same as the object in Java. If we are referencing the same object with two different variables, one change in one object will be seen also from the other variable. And so there are currently three types that are supported by Solidity, which are structs, arrays, and mappings. And what is important is that when we define a reference type, we should provide the data area where the type is stored. That can be storage. That is, if we want to store this variable as a state variable, which means on the blockchain, and it is persistent and modifiable. Then we have memory. This is used in the scope, for example, of a function, and this is stored in memory and exists while a function is being called. Is non-persistent but modifiable. Then there is call data that is similar to memory, but it is read-only. This non-modifiable, non-persistent area where function arguments are stored behaves mostly like memory, and it is non-persistent and non-modifiable. So we have um, arrays that contains a list, they are a list of items, like in all other programming language. But we have two types of array: fixed size arrays and dynamic size array. So if we define an array with this expression, so we are creating a fixed size array of, for example, k elements. If we define it this way, we are defining a dynamic array. The array elements can be of any type, including mapping and struct. And if we mark the array as public, we get a getter that will return the value of an element at a specific address of the array. And this is a code that demonstrates both fixed size and dynamic arrays. So we can, this is called test arrays. Okay, we can try this here. Okay. Here we are defining two state variables. This is a dynamic array. This is a fixed array. Here we are defining instead an array as local variable. Okay. And here also we are defining this is a method that I've created because it is not possible to make this assignment here, as you can see it here, for arrays that are not uint 8. For example, if you call, I don't know, here test this array that is uint 256, which is equivalent to uint, this gives us an error because it tells us the uint 8 3 memory is not implicitly converted to the expected type uint 256. So if we want to define locally fixed side array which should of the type uint, we can start from a uint 8 array and then assign each value of this array with this for loop. And of course, each time we read an element of this array 8, we must convert it to uint. Here we are instead creating local dynamic array. Also here we have a similar problem as before. This is a type of declaration. This is a particular type that even though this array should be dynamic in theory, in reality, memory arrays cannot be resized. So once we declare it this way, we cannot add or remove elements. This is important. And we also create this array with a for cycle by reading this other array and converting it to uint. And then we have created an helper function which make a comparison between the two arrays in order to establish that if they are equal or not. And this can be done in the traditional way with a for cycle, or for example by using the API.encode function and converting and using the hashing algorithm GECAC 256. So we can compare it in these two ways. In a traditional way with a for cycle by comparing each element, or also with the hash of the entire array. And also here we have a test function that makes use of these two functions just to demonstrate that the local array that comes from here, from this method, is equal to the dynamic array that we have defined here in our global variable. So always bear in mind that it's different to define an array as global variable respect to define it as a local variable. And of course, we can also test this contract. We deploy it. Okay, and then we run the test function. Okay, everything went fine. So also this is working. For example, here you can see that this variable local array dynamic returns the whole array by returning it this way when we return the variable. While here, if this was the getter I was talking to you about, here you can access one element. For example, let's see, I want to access the element 0 of the dynamic array. The value is 1 because the dynamic array, this is the element that we are evaluating here. So it is a getter for a single element. Also here for array fixed, if we say for example 2, it gives us the value 3, which is this one. So if we want to get the whole array, we should create a variable that returns a function that returns the complete array. And so okay, also this is fine. And so the difference here here is that in a local variable, when we have a local variable, a static array can be defined in this here, and a dynamic array can be defined with the new operator. This is um, also stated here, and also um, as we said earlier, it is not possible to resize memory arrays. Memory arrays means that they are always local to the local arrays, so to a function. They are not state variables, otherwise they must be storage, and so they don't have the push member that we will see later on. And so we must take care of this because we must know the length of the array in advance. Okay, also here is saying that we could also specify assign the single element of the array. This is similar to what we have done earlier with the with the for loop, but of course not always can be used for loop. And the methods of the array that are important are, for example, length, which returns the length of the array, like in JavaScript. Push, which adds an an element to the array, which is zero initialized, for example, for integers. And of course, we can also specify an element, the element that we want to add at the end of the array, um, by calling this overload of the push function. So we have a push function without arguments and push function with with the element that we want to push at, at the end of the array. Then we have the pop function that removes the last element of the array. Here we have another contract that demonstrates the all this function. This is called array this contract. So we have it here. And so basically there are a bunch of methods here. This is a constructor that initializes the array. As you can see with the push method, we are adding sixth element. Then we have the size function that returns the length of the array. Get all, we have seen earlier, returns the whole array. Then here we get the array at a specific index. We append this element to the end of the array with the push function. Here we remove the last element with the pop function. Here we delete an index of the array, which means that we default it to 0, becomes 0. Then we use, I've created an add all function that receives an array and adds it to the end of the existing element of the array. The set function that sets a specific index of the array is empty function that control if the array is empty. Then we have the array equal function that is the function that we have discussed earlier, and the get test array that returns an array that we will use to test here to make the tests. Here, since um, we are assigning the value of the array in the constructor, here we are asserting that the size of the array is 6, that the array has the same elements of the returned by this function here. We are testing here the get function, the isEmpty function. Then we append an element. We make some tests with the get the size function. Remove last item. We check the size. We remove an index. So we check that the element is 0, and we set the element at the index 5 at 6, and we test also this function here. So we can also deploy this contract. Okay, and here we call the test function. Okay, everything went fine. So there are also the slice of the array. Like in JavaScript, you can take a portion of the array with the start and between a start and the end index. And also then we come to structs. Struct is a data type very similar to the C programming language. And basically we are defining a set of variables that should be together, should be grouped together as a single unit. And here, for example, the book is struct that has the properties name, writer, ID, available, and so on and so forth. Okay. So we can access here saying that we can access a variable, for example, name with the dot by using the dot operator. So if we create a variable my book, which is an instance of book, we can access the name by you typing mybook.name. And then here's another example of struct. Okay, that we can to-dos. So here we have the to-dos contract that we paste here. Okay. Here we define a struct that has a string, two properties. String, which is the text, and the bool that um, tells us if the task has been completed or not. Then we define a private variables, which is an array of structs to do, which is private, so we don't get the getter. And so here there is a constructor that initialize this variable which creates three elements of the to-dos array in three different way. Here we are using the push method with this expression here. So we are passing here to the to-do struct the text and boolean completed. Here we are specifying text semicolon our text and completed semicolon the value of completed. And here we are defining the we are using the dot node, the dot operator to set the text, and we know that the boolean defaults to false, so we are not defining it, and we push it into the array. So we have the get function that retrieves an element of this array at this specific index. Then we have the update text that allow us to update uh, a specific item at this index of the array, but we are updating only the text. And we also we can mark a task, a to-do as completed by taking the element of the array at this particular index, and since it is initialized to false, we with this not operator we mark it as true. And then there is the compare string function, which is the same that we have discussed before, and the test function that makes some tests. So in the first case we retrieve the first element, we compare the strings. So this is the expected, this is um, the string of this element 0. And we also assert that completed is false. Here we are doing similar tests. And then here we apply the function update text, the function toggle completed to the second item. And then we compare the strings, we make sure that the text has been updated with this new um, string here, and that the variable completed has been set to true. And also we can deploy this contract here. Okay, this is the deployed contract, and we call the test function. Perfect. So this was it for structs. Another important type is the mapping. The mapping is similar to an hash table which means that it has a key and a value. But it is important to note that Solidity does not store the keys. It just creates, stores the kekak 256 of the key and the related value. But if we are planning to, we need to use to know the key, we should save them in some data structure, like for example an array, because we cannot know with this data type what are the keys. So it is a classical key value data structure, and key type can be built in um, with byte, strings, contract, or enum type, or also can be used as keys, mapping, structs, array types, and sorry, no, are not permitted. Sorry, so mapping, structs, and other array types are not permitted. Sorry. While the value type can be any type, including mapping, array, and structs, and also, of course, strings, integers, and so on. And as we said earlier, the mappings can be thought of a hash table. So each key is mapped to one value. And they are virtually initialized with every possible key that is mapped to a value whose byte representation is all 0, which is the type's default value. However, as I said earlier, unlike hash table, the key data is not stored in the mapping, only the kekak 256 hash is used to look up the value. So they apply this algorithm to the key to look up the value, but the value of the key itself, it's not stored. So mappings do not have a length and do not um, um, we cannot retrieve the keys. Can only be located in storage, so as the state variable. And there are also other restrictions. For example, they cannot be used as parameters or return parameters of contract function that are publicly visible. And this restriction also applies to arrays and structs that contain mappings. So state variables on mapping can be marked as public, and Solidity will automatically create a getter for us. Also, this is another important point. Mappings are not iterable. If we need to iterate over a mapping, we need to use an iterable mapping. So there is an example here on the Solidity data types. And so this is an example. So we take this code and we paste it into a remix IDE. This is called mapping. Okay. So this code creates a mapping from integer uint to string. In the constructor, we define two elements of this mapping: key 0 to value hello, key 1 to value world. So we define here some of the most classic method to interact with the mappings, which is get to retrieve an element from an address. If you give the address, you will retrieve the corresponding value. Set to set a particular key which is mapped to a particular value. remove to reset, so um, to reset the value of at a particular key. So this means that it will become an empty string. The test function, the compare string function, which is the one we have seen earlier. Then we test this function, and we get the first value, and we make sure that it is equal to hello. Get the value at index 1, and we make sure that is equal to world. Then we set at this key to the value our u, and we assert that this new effectively it was set in the map. So we retrieve the value of the map. We can at the index 2 at the key 2, and we make sure that is equal to our u. We call the remove function at the index 2, which means that this value here must become an empty string, as we said earlier. So we can deploy also this contract. This can remove. This is waiting, so we confirm. Okay, our contract has been deployed, and we can call the test function. We confirm. Perfect. So our contract, the mapping type has been demonstrated, and also in the document you will see here a part that explains how you can import this Hardhat slash console.sol, which is a contract that allow to use the console.log, so to print in the console in Solidity. And this could be useful for those like me who like to print some values in the console, but of course this can be done only for strings and bools, because for example if you use it with integers, int or uint, you must convert them with to strings with the function that we have seen before. So guys, we have reached the end of the video. I hope that it has been useful. Let me know what you think about it, and also if you have any questions, I will try to reply as soon as I can. And thank you for watching, and see you in the next video.